Hello everyone, myself Kanish and my register number is URK23A1139. Today I'll be explaining this Python code that builds an encoder and decoder LSTM model using TensorFlow and Keras. This type of model is commonly used for sequence to sequence tasks such as language translation, text summarization, or chatbot response. The first thing we are going to do is import libraries. At the start, we import all the required libraries, TensorFlow and Keras layers to build the model, NumPy for handling numeric data. We'll be using LSTM layers, which are a special type of recurrent neural network that can remember patterns over long sequence, perfect for processing text or time series data. Defining model parameters. Next, we set a parameter called Latin parameter. This represents the size of hidden state inside the LSTM, basically how much memory or learning capacity the model has. A higher number means the model can learn more complex patterns, but it also takes more time to resource to train. The next one is building the encoder. Now we build the encoder part of the model. We start by defining an input layer called encoder input, which can take sequence of any length, each having 100 features per time. Then we add LSTM layer with 256 hidden units. We set return state is equal to, which means this LSTM will not give on its output but also the hidden state and the cell state. These two states, state H and state C, represent the encoder has learned from its input sequence and they will be passed to the decoder. The next one is we are going to decode, building the decoder. Next, we create the decoder which will generate the output sequence. We define another input layer called decoder input, also having a shape of none underscore 100, meaning variable length sequence with 100 features. We add another LSTM layer, this time with a return sequence. True is equal to return state true. Return sequence is equal to means that the decoder will output a sequence, not just a single value. We also pass the encoder stage as the initial state of the LSTM. So the decoder starts with context learned by the encoder. At the last, then we add a dense layer with 100 neurons and softmax activation function. This layer predicts the probability of each possible output feature at every step. The last is defining the model. Now we can combine the encoder and decoder in one full model. The model takes two inputs, encoder inputs and decoder inputs. The encoder inputs gives the input sequence and the decoder gives the shifted target sequence for training. And it outputs the final decoder sequence. We compile the model using Adam Optimizer, which helps the model learn efficiently and categorical cross entropy loss since this is the classification problem over multiple output categories. The summary is finally we print the model summary using model.summary. This shows all the layer, their output shapes, and total number of trainable parameters. And this is the output. And thank you.